Algebra Geometry 3 classes, good morning, good afternoon, or good evening. With this set of notes, we'll actually finish up the material from 10.2. It will look very similar to what you guys saw in 10.2 day 1. The only thing that we're going to do is add in one additional step that can occur with dividing rational expressions. So, to divide a rational number by any non-zero number, you multiply by its reciprocal. You must write the excluded values before you flip the fraction after the division sign. The excluded values are any numbers that make the denominator 0 or the numerator 0 after a division sign. So, here we have 3 over 2 divided by 14 over 6. So as far as what this says, to divide a rational number by a non-zero number, you multiply by the reciprocal of the second fraction, meaning we are going to flip that second fraction. Now, from here, it's kind of a matter of how you choose to do it. You can either multiply first, or you can reduce first. Either way, you will end up having to do some reducing and multiplying. If you do the multiplication first, 3 times 6 is 18. 2 times 14 is 28. Now, as far as how you can reduce 18 over 28, these will both divide by 2. 18 divided by 2 gives us 9. 28 divided by 2 gives us 14. So, certainly this is something that you have done in the past. Now, as far as these problems go now, kind of using some actual algebraic division, there's a couple of things you can do. You can either include your exclusions first. I actually like to go ahead and flip before I worry about that. I know it says here if you initially worry about the numerator, I like to go ahead and do my flipping first and then worry about my exclusion. So 12y 7z squared times 2z over 3xy. And now we can just worry about exclusions for everything in our denominator. Again, it's kind of up to you. You can either worry about exclusions up here or down here. You'll end up with the same things either way. So we have x, y, and z all in our resultant denominators. Those all cannot equal 0. Now, with as far as what we have from here, again, we're just going to multiply across. 12 times 2 is 24. YZ over 7 times 3 is 21 XYZ squared. Now, as far as what we can do from here, 24 over 21 will reduce. They both reduce by 3, so I can make that 24 divided by 3 is 8. 21 divided by 3 is 7. Now, as far as from here, the y's will cancel. You just have one y, both top and bottom. And then as far as the z's go, z to the first minus z to the second gives us z to the negative 1. Since there's not anything to actually combine with that x, I'm just going to leave that in our denominator. Now, your final step in this problem is to move this negative exponent back down. So it's 8 over 7xz. And, there's no right or wrong order for your variables. I always say usually you see them written in alphabetical order, but again, if you had 7zx, that would have been fine. But that is an introductory dividing rational expressions problem. Now, for example 3, one of the things that I do always like to do is anytime I do not have a fraction, just make it x plus 3 over 1. Now what I'm going to do is keep our first fraction and flip our second fraction. Now, as far as the excluded values go, x squared equals 0 is 1. The other one is x plus 3 equals 0. So, subtract 3 for this one. So, one of our exclusions is that x cannot equal negative 3. For the other one, I'm going to take the square root to cancel out my square, and when I do that, the square root of 0 is 0. So, our two exclusions are negative 3 and 0. Now, as far as what we are going to have to do to work with the rest of this problem, we are going to have to do some reducing, and do not cancel these x squareds initially. Because of the addition here, we are going to have to factor before we can do anything with canceling. Unlike this one, we don't have any addition or subtraction, so you are able to reduce very easily. So, 4x squared plus 4x plus 3. Again, I am going to have to factor. What multiplies to 3 adds to 4. Well, this one is actually very convenient. There is only one thing, or one set of numbers that multiplies to 3, and those are 3 and 1. So when I factor this numerator, it will be x plus 3, x plus 1, again, just for now, over x squared, times 1 over x plus 3. Now, as far as what we can get rid of here, the x plus 3's will cancel. And that leaves us with x plus 1 times 1. Well, when you multiply that, it's just x plus 1. All that's left in our denominator is x squared. Now, here again, I was only able to reduce or cancel, however you want to phrase it, the x plus 3's when they are a like quantity. I, again, cannot do anything with x plus 1 and this x squared because I do not have a quantity. So this is our end result here. All right, the next one on this page anyway, if you are printing these off, again, x squared minus 9 over 8x cubed times 4x over 6x minus 2. So, as far as our exclusions go, 8x cubed equals 0, 6x minus 2 equals 0. Well, for this first one, divide the 8, and then if I have x cubed equals 0, this is something where we're going to actually take to cancel out a third power, a third root. Well, the square root of 0 is 0. No matter what root I'm using, be it a square root, be it a third root, that will always just be 0. Now, for the other denominator, add the 2, and then when I divide, you can either leave this as a decimal or a fraction. I will admit I prefer leaving fractions as exact values. If you want to tell us its point through repeating, you can. The only thing that I am going to say we would want you to do with that 2 over 6 is just go ahead and reduce it down. They both divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So our two exclusions are 0 and 1/3. Now, as far as what's going to happen here with this, the x squared minus 9. When you have only two terms, the first thing you can always look at, is there a GCF? Well, there is nothing that divides out of both x squared and 9, other than, I guess, technically 1, but that won't really help us. So, next thing, look at, is it a perfect square with the constant value? The square root of 9 is 3. So this will factor into x minus 3 and x plus 3. Well, the next fraction, again, we can't do anything initially with the 4x. We'll talk about how that will work here in a moment. There is a GCF that I can divide out of 6x minus 2. I can divide a 2 out of both of these. And so when I divide 2 out of 6x, it leaves 3x. Divide 2 out of minus 2, a1. Now, in terms of what we are able to get rid of here, I can cancel out this x, and then I can reduce the 8x cubed to x squared. The only other things that we are able to reduce here are some numbers. Well, what I can do for this, you can either reduce the 4 and the 8, or, I'll be honest, I actually prefer to just look at it, hey, I have a 4 here in the numerator, a 2 in this denominator. Well, I can get rid of that 2, and then this 4 reduces down to a 2. So, in terms of what is now left in my numerator, I have a 2. I usually write that coefficient out in the front, and then I have my x minus 3 and x plus 3 over the 8x squared and 3x minus 1. Now, as far as what we have left here, there is actually one final step that we can reduce, and that is my 2 and the 8. They both divide by 2. And so that is going to give us x minus 3, x plus 3 over 4 x squared times 3x minus 1. So this one, not as much reduced here. Again, the 3x minus 1 does not cancel with either x minus 3 or x plus 3. You have some similarities, but again, there's not a true overlap, so we cannot cancel any of those quantities. All right, for the final two examples, now we have a squared minus 5a plus 6 over 2a squared divided by 3 minus a over 4. Well, again, what I'm going to do here is go ahead and flip my second fraction from the start. So 2a squared equals 0, 3 minus a equals 0, divide by 2, a squared equals 0, and then when I take the square root, one of my exclusions is 0. Now for this next one, subtract the 3, negative a equals negative 3. Your final step, divide the negative 1. And a equals 3 is our other excluded value. Now, working with what we have here. For this numerator, we have to find what multiplies to 6, adds to negative 5. Well, in terms of what multiplies to 6, either 1 and 6 or 2 and 3. Well, in order to multiply to a positive, add to a negative, both of our factors have to be negative. So, what multiplies to 6 adds to negative 5, negative 2, and negative 3. So, a minus 2, a minus 3 over 2a squared. Now, the one thing that is a very common algebra issue that we see is you look at this one and think, oh, there is not anything I can actually factor here. There actually is a GCF for this problem. I am able to divide a negative 1 out of each of these because right now the 3 minus a and the a minus 3 do not reduce. These are opposites. So I'm going to divide a negative 1 out of that. When I divide negative 1 out of 3, that becomes negative. Divide negative 1 out of negative a, it is positive. So from here, now what we are able to reduce. I have a positive A, negative 3, negative 3. So even though these are written in a different order, they are equivalent. You can even rewrite this as A minus 3 if you want, but those are able to cancel. Now, there is one other thing that we are able to reduce here, and that is my 4 and my 2. Well, 4 divided by 2 will make this a 2. 2 divided by 2 makes that a 1. So now all that is left, we have a 2 in our numerator times A minus 2. You certainly can distribute that. I will usually leave that in factored form. And then I have a 1 and a negative 1 A squared. Now, the only other thing that I am going to do here with this is it's usually preferable to not leave that negative in the denominator. If I take 2 divided by negative 1, that's just going to become negative 2 A minus 2 over A squared. So, again, just a little bit better form of an answer there. Again, this A minus 2 is a quantity, so I cannot reduce with this A and that, one of the A's and that A squared. So, there is that one. Now, one final example. Again, I'm going to start out by, since it is a division problem, flipping to x squared over 2x plus 4. So to begin, our excluded values. Well, for this x equals 0, I do not have to do any solving. For the other one, 2x plus 4 equals 0. Subtract 4 and divide. And when I do that, our other exclusion is negative 2. Well, 3x squared plus 6x. You only have 2 terms, so we do not have to worry about any trinomial factoring, product, sum, multiplies, and adds. It's just going to be a matter of what are our GCFs. Well, out of 3x squared and 6x, I am able to divide both a 3 and an x out of that. Now, if I divide 3x squared by 3x, that leaves an x. If I divide 6x by 3x, that leaves positive 2. I have an x here from my original numerator. I have an x squared, from my original denominator. I have an x squared from this numerator. And then, much like what we just did, there is a GCF that I can divide out here. Out of 2x and 4, I can divide out a 2 from both of those. Now, when I divide the 2 out of 2x, leaves x. Divide the 2 out of 4, leaves 2. Now, in terms of what we are able to reduce or cancel, definitely can reduce my x plus 2's. There is one other thing that we are able to cancel. I have a 3x here and x here. I can get rid of each of these x's. And so now what's left in my numerator is 3x squared over, all that's left in my denominator is a 2. So there is a 10.2 Day 2 assignment on Schoology that does correspond with the division of rational expressions.